Good.
Yeah, cool.
We're ready to go then, Bill.
Okay, great. Good afternoon, everyone. I'm Bill Deaslin. I am, I don't know, I'm not quite a board member of Ezra. I'm sort of like a safety advisor to Ezra that gets invited to lots of meetings. How's that? I'm also a judge for the construction of rockets. And at the event on Tuesday, you'll see me doing safety reviews of rockets, and then probably the rest of the event, you'll just see me wandering around, mostly in the prep area, making sure that people aren't doing silly things like, believe it or not, I've caught people smoking. I mean, it's kind of dumb, you know, but anyhow, that's kind of my role in all that. And then today, you know, obviously we can't do a comprehensive safety review of a rocket virtually, you know. So that'll all happen on Monday and Tuesday of the event at the convention center, where if you've been there before, you know, you bring your rocket in and you set it on a table, and a couple of old guys dig around on it and ask a bunch of questions and stuff like that, and then you're ready to go. But really, the intent of this meeting is to see that either your rocket is completely ready to go, or it is fundamentally a rocket. Okay, what we're trying to avoid is people showing up in Las Cruces with tubes and fins and, you know, some fabric that they're going to make a shoot out of in their hotel room. So really the goal, you know, you're not gaining or losing points today or anything like that. We'll just kind of muddle through your design. It looks like we'll look at your motor too, and we'll go from there. So with that said, it's all yours. Start where you want. If you want to start on the Bernie side or the pointy side, it's up to you.
We'll probably start at the nose cone and work backwards.
Sure.
We think we're probably gonna have a lot of discussion on the motor, so we'll leave that to the very end of the
Okay.
To my right, to your left, depending on the screen, is Emilio. He is the airframe gentleman that is taking over as far as airframe construction and the no all be all of fiberglass. And to the left is my co-lead, Haven. He is also the lead for propulsion. And then, as we've talked many times, my name is Jared. I am the project designer.
All right, fantastic.
So let's get the airframe up here.
Yeah. And hello, Chris.
Hello, I'm lurking.
Sure.
I'm in an inopportune location, so I'm not going to turn the camera on and distract.
Probably the camera back in there. Just one. Okay, so our entire airframe is a COTS manufactured airframe. It is by Wildman. It is a 6-inch diameter and made up of various lengths of tubing. Overall, it is 12 feet and 8 inches long. It consists of 3 primary sections. Starting at the most forward end, we have the nose cone. It is separated into a separate section with a switch band. Inside of our coupler is actually going to be where our payload and our avionics bay actually mesh together. I'll have Emilio walk through exactly what that is. You want to show them more detail? Yeah. Closer to the camera. Already taking this on.
Yeah.
Okay. This is the av bay design. You can see here it's set up into basically trays on either side of the payload in the middle. The payload is not yet complete. It's going to be these square sections that will all be bolted together, and everything will be sandwiched by the 2 fiberglass bulk plates at either end. You can see we have space for batteries back here, and everything is nicely labeled. I don't know if it shows up on camera or not.
I guess I did, catch it there. So okay.
Yeah.
Yep.
There's a little bit. I mean, it's reversed, but.
No, it looks correct to me. Yeah. all of that,
Anyways.
all of that's printed?
Yes, it's all printed.
Okay, and do you have any data on the material you're using for printing? I'm just remembering that New Mexico is hot.
Yes,
And
it's all PETG.
okay, all right, good.
Yeah, that's basically the App Bay design. We're using an AIM Extra for the primary flight computer, a Stratologger for the backup, and we have two lithium iron phosphate batteries, the LifePose, each powering each avionics system set independently. And then for arming, we have two, they're MissileWorks screw switches is what we're using.
That's my favorite.
Yep. I quite enjoy those as well.
Right. It's worth paying the $2 for the little plastic doodad that retains the screw.
Yeah,
yeah.
I 3D printed some. I have my own.
Okay, that's great. Just I wish I didn't have a lot of experience with students turning screws the wrong way and having them fall out of screw switches. But
yeah, that should not be possible with ours.
Okay, fantastic.
Okay.
So as I mentioned, that's going to be mated up here with our forward coupler. Our forward coupler is 18 inches in, actually, I'm sorry, 16 inches in length. It is a always ready rocketry Bluetooth 2.0 coupler, but it's been reinforced on the inside with 2 wraps of fiberglass.
It's hard to see on camera.
Oh, I can see the line. Yeah.
Yeah.
Mm-hmm.
Below it, what is that, a 36-inch section?
Yes.
Yeah, it's a 36-inch section of fiberglass. That is where the drogue, it's a drogue, but it's a streamer. So that's where our drogue recovery side of things will be located. It does have a separation point in the middle of it. However, it will be non-separable in flight. That's held together with 8 quarter-20 bolts with internal lockers that will already be epoxied into place. So we don't have to fiddle with screws when we get out there. And that is part of the original Wildman kit.
You should see that they've been epoxied in there. The little epoxy mount nuts basically on the back. It just greatly simplifies assembly.
And then,
Sure.
do you have any other ones we have? Or do you have the black ones too?
These are the nuts.
Okay, and then to ensure that none of the drogue recovery system gets snagged, each one of these 3D printed ramps will go over that nut location on the inside to provide a smooth surface.
Oh, I see. Okay, yeah, I get it. Just so you don't get hung up on it.
Yeah.
Yeah.
So we didn't want to have anything of that. And then after our 60-inch piece of body tube, we have a further 18-inch small section of body tube that is going to be our removable fin can section. Cool. Now we'll talk about fin can, fin designs, all that kind of stuff. So the fin can itself, this is the second iteration of what we've done with it. The first fin can had fins that were about 1.25 inches thick at the bottom. Just too much drag overall. Our redesign of fins are just shy of 1 inch on the bottom and taper up to 1/4 inch on top. And like we've talked about a couple times, they are like a double diamond style design. Can you hear me one actually? What we did is essentially made it impossible for different frequencies of vibrations to build up through it by one, ensuring that along the root, the actual root itself is extended. And then upon the leading edge, if I can get this in the right direction, you can see they go from a thick to a thin cord, and that provides us different frequencies to prevent a harmonic resonance from building up.
That's really cool. You put a lot of time in those.
Oh yeah.
Yeah, second set. I think between the 2 sets, we probably have a couple dozen man hours into making those.
Something like 20 hours of sanding or something like that.
Yeah, 20 hours of sanding up at this point or something. Yeah, it's been a lot of sanding. So with our fin can, we actually wanted our fin can to be a complete separate system in case we had damages down the road or anything with that. One thing we wanted to make sure we didn't have is our fin can turn into a spin can. and actually rotate around the motor, because the only force that will be holding the fin can to the main body tube is the outer diameter of the rocket motor, along with the thrust plate at the very back of it. In order to prevent that, we created a fin lock system. Essentially, this system has a male and female part. One will be on the main body tube, one will be on the fin can. There's 4 of these, and so once they interlock together, we don't have to worry about the fin can actually spinning on these axes.
It's cool.
These were manufactured in-house using our CNC machine as well. One of our members.
Okay.
Up to this point, do you have any questions on the airframe?
No, it's all making sense, and it's also very familiar from reading your reports. So
We're a little behind on the fin can from what we originally had proposed. We had a catastrophic, unscheduled disassembly of our rocket motor, whatever terms you'd like to put in there. That took a little bit more time to sort out than we thought it was going to take. But we should be. What do you think in the next
I can
4
have
days?
I can have the pins done by Saturday.
So Saturday, we are shooting for a full-scale launch on the 25th or 26th of this month, testing all systems. So the whole rocket will be done by then.
okay.
Okay, let's pull this down and then move the motor up, because that's what we're going to talk about. So while they're doing that, I will talk on this. The main recovery system is been changed. We were going to self-sew a parachute. Unfortunately, my mother, who was the one that's actually going to sew it for her, I sent 16 gores down to her instead of 20 gores. And by the time I would have been able to get the new fabric in and cut, we would have missed our launch opportunity. So I went ahead and bought a 14-foot Irish parachute from Fruity Shoots. So that will be our main recovery. And then we still have a 125-foot by 14-inch wide streamer that will be our drogue deployment. Both of those are going to come down on 2 brand new sets of One Bad Hawk harnesses. They're 40 feet in length. They are half-inch tubular Kevlar, and each one will support 7,200 pounds of thrust. We'll be okay on this. We did the math on it, and in worst case scenario, should the parachute instantaneously open up and provide a shock load, it will be 6,300 pound-feet of force on that shock cord. So we'll still be within our safety factor of that.
All right.
Okay, so this is the primary system of our motor. This is a 56-inch long and 152 millimeter diameter casing. We'll start at the forward end. The first thing we had, Amelia, if you could lift it up, is a retainer ring. The retainer ring is 2 3/4 inches in length, and it is held together by 16 1/4-20 bolts that are spaced radially from each other on every 45 degree, and then the second channel is off shifted by 22.5 degrees. Essentially, we took 360 degrees, divided by 8, and then off shifted it. Followed by that is a spacer ring. This gives us the ability to run 3, 4, 5, or 6 grains, depending on how many size spacers we want to make to change the motor configuration. And then this will be our forward closure. The forward closure is 2 3/4 inches. It uses 2 1/4-inch O-rings. They are Burma O-rings, so they are both oil, gas, and water rated. And then the hole in the very top of it is for a 3/8 by 16 threaded shoulder bolt that will provide us our retention point for our drogue harness. Oh, I'm sorry. And then we also add, that's 1/8 inch.
1/8 inch.
Yeah. Then we are also, the nice thing about us flying the AIM Extra system is it allows us to pull pressure off the motor during flight. So we opted to put an 1/8 inch MPT port at the very top of our motor. One, we needed this for ground testing purposes, but then secondary, this will allow us to pull in-flight pressure as well, so we can get live and real world data.
Cool. I'm very familiar with that. We actually we did that last year. Same size motor too. So,
Okay.
Yeah.
Good, we're excited to see what we can get from it. Okay, so from here, we'll move over to the actual boat tail. I did want to display, we briefly talked about this in the reports, but we do have 2 sets of radial bolts up here with a single set at the actual aft end of it. This concept was proven in validity when we went to ground test this. We actually experienced an overpressure. Estimates are
Like over 3,000.
north of 3,000 psi based on the initial. We sent this assembly to about 400 feet in about 5 seconds.
Did your motor flame out then? Because that big drop in pressure.
It flamed out, and then once the pressure had been released,
Yep.
the actual bonded in grains had enough initial thrust to lift themselves out of the motor. They moved over 6 inches and speared themselves on
Like a fence.
like a fencing stake.
Oh, cool.
And then we had about a 22-second firework fountain. So
Sure. So they had enough heat that they were able to reignite, but
Yes.
at first it flamed out.
yes.
Yeah. Okay.
So we did prove this concept on the fact that we wanted to know there was an engineered point if this motor was going to fail. We knew how it was going to fail. Worst case scenario we did not want is it to be middle of flight in Cato and send its contents up into the middle of the rocket, destroying our avionics, our recovery, and essentially everything that we had that was of high value. So we designed it so if it was going to fail, it would first kick out the bolts at the very aft end of the rocket. And if for some reason those still held, then the modular system underneath it would crumple and relieve the pressure. Thankfully, the bolts sheared when we had the overpressure event, and we recovered all 3 of our items without issue once they hit the ground. So in order to cut manufacturing costs, and not have to buy a $2,000 chunk of graphite to fit inside of our boat tail motor, we opted for a Russian doll style motor assembly. The outside of it is a 7.5 inch chunk by 6 inch, I'm sorry, by 5.5 inch 6061 aluminum boat tail. It essentially works as the carrier. Next to it is a chunk of linen phenolic. We chose this because it has a high propensity to withstand heat. And finally, what sits inside that is our graphite nozzle. So they all mate within one another to give ourselves a modular system. So if we need to swap nozzle sizes, we can without having to remachine an entire $1,500 chunk of aluminum.
Did you turn that graphite on campus?
We did.
Yes.
We've at this point we've turned
We've probably made about a dozen nozzles.
a dozen nozzles or so at this point in time. What we do for safety factor is we have 2 vacuums running at the same time. Both of them have HEPA bags and HEPA filters installed in them. And then the work surface, anywhere where that graphite could touch, is covered in rosin paper that is sprayed with WD-40.
Okay. Yeah, a lot of university teams are not allowed to turn graphite because they've created colossal messes at their schools, and so
Yeah, we've built up a really good rapport with the machine shop manager here at UTSA. There was one time when we were machining a nozzle, and it ended up, it was one of our first larger nozzles, because before we were just doing 54 millimeter ones. The one time we moved up to our 98 millimeter nozzle, we ended up creating a bit more of a mess than we anticipated, and so we kind of stepped back, designed our entire carbon capture methodology, and then we're able to go back in and remachine larger nozzles like this with significantly less mess. So we're very grateful that Dave has allowed us to go in there and machine these nozzles.
And are you able to reuse the phenolic, or is that a one and done?
We're
Not sure.
we're in an experimental phase of it right now. We do have brush on / paint on ceramic that we can put on the back of it. The ceramic paint is good for 5,000 degrees Fahrenheit. We had it on there for the initial hot fire. Unfortunately, I put it on too thick without letting it cure properly, and the ceramic separated. So we ended up just saying, hey, we'll run it, and if it destroys itself, we'll make another one. But before this next hot fire, we're going to re-rough it up and actually reapply that ceramic to see if we can't make it a multi-use item.
So you did one ground test that you had a catastrophic failure. I mean, it blew up, and now you're planning. I guess you'd call it a dynamic test, right? Because you're going to fly it.
So we actually are planning on actually staying with the program itself here this Sunday. We're going to re-hot fire the motor as it is with our new propellant formula. It is a blue formula that we have a lot more characteristics on, and that will satisfy the initial requirements to make sure that the motor withstands the pressure it needs, and we can get the data to ensure, hey, it says we're going to X altitude, that's what we get the pressure data from.
Mhm.
Then the following weekend, we are burning a non-sister motor that we will make off to let it fly. And then the sister motor of the hot fire burn will be set aside, and that's the one we will fire at Spaceport.
Okay. And are you bonding those grains into the phenolic?
Yes. So prior to the actual launch, the liner is cut to size. It is dry fit to make sure that all the components mesh well with it. The grains are cut and measured. And then from there, they're flattened, and then we actually clock them with witness marks to make sure that they fit together the best they can. Once they're done with that, the whole system is stacked on top of the nozzle assembly that is covered with saran wrap to make sure it doesn't bond to it. We coat the whole outside of it with silicone and then slide the grain liner over the top of it and then let it cure for its cure time. We've done it as fast as 4 hours with very, very high very, very fast curing silicone. We also have silicone that's 24-hour dry stuff, depending on how fast we need to get the motor assembled for. Once it's in that state, then we have all the bonds bonded together. Probably the whole reason our motor survived the way it did is when we had the Kato, the whole bond stack came out as one versus having individual torches pointing in different direction. So we had a very, very concentrated flame in an area, thankfully, that didn't damage any of our parts.
So the bonded grains actually left the phenolic, or did the whole?
Yes.
Okay.
So if you imagine this tube sitting up straight, we had our initial explosion, which was just a flame puff, which we didn't realize at the time was the boat tail letting go. There was a short pause, and then a little bit offside of where the test stand was, you could see the motor igniting.
The low pressure burn, yeah.
Right. What
So,
we didn't realize until we actually went back and saw the video footage is the entire 40-pound mass of propellant lifted up as a single stack, moved over, and then skewed itself on one of those fence posts. But that was mainly because we had the entire thing bonded. We do that in case one of the grains decides in flight, if it wasn't bonded to let go, we don't want it to clog our nozzle assembly and have a Kato in flight. So we bond them to make sure that none of those grains under the weight or thrust of themselves can move it.
okay.
What else on the end motor do we have?
And then there's just the last actual part that needs to get machined for this motor. It's not necessarily required for the motor to operate. But however, when we integrate it with the actual flight vehicle, originally our plan was to have the boat tail have this wide part of the boat tail here be the same diameter as the airframe. However, as you can see, it is no longer the case. In order to avoid spending an exorbitant amount of money on an aluminum stock for this, we sized down our boat tail. However, to actually provide a thrust ring capability for the motor, we're basically just going to take this piece of aluminum stock and machine a ring out of it.
I was going to say, you're making a really big washer.
Basically, yeah. So when we install the boat tail here, you'll notice that when we actually line up the holes here, there is a bit of a space.
Yep, I can see it. I can even see it with that. Yeah.
Yeah, basically just exactly as you said, big old washer right there, and then that'll press up against the outer part of the airframe.
All right.
Is there any glaring issues or questions you have regarding our motor. I know we haven't been able to send like an actual test fire at this point in time. We had to kind of go into crisis management in order to
Sure.
regain funds and to get a different formula characterized and up and running at that point. But we're slowly getting back into it and ramping up timeline. We should be hot firing by this weekend and then a test fire by next weekend.
Okay. Right. Yeah, I'm by no means an expert on making motors. I mean, I'm surrounded by students that do it and things like that. But you know, so I can't. The only thing I don't entirely understand is bonding the grains with silicone. I'm used to that it's you know, like Gorilla Glue or something, you know, that's holding it fast to the phenolic.
So the reason we didn't go with a glue type adhesive substance is things like Gorilla Glue or Glue Max by Elmer's Glue. They are hygroscopic in order to dry themselves. So that therefore puts a compression load on the grains. By doing silicone, we just have a natural air drying environment where once the liner is put together, we don't have to worry about that static pressure moving inwards and cracking the grains.
Okay. Maybe when we get that Tuesday, I'll come over to your booth in the convention center and look at that. You can walk me through or talk me through that. As my understanding would be that you're bonding those grains to prevent grain collapse. You know, so you'd want them sort of adhered to the inside of that phenolic, but that silicone, it doesn't sound like it's really attaching. I mean, because you were able to throw all those grains out of the phenolic. Yeah.
No. So the actual
whole thing came.
Bonded
Okay.
grains,
Baby and all. All right. Okay.
Once the grains are bonded with the silicone, I mean, we don't do it because we don't want to incur that issue of one of them falling out, but you can actually lift up the stack and the grains stay in place.
Yep. Yeah.
So once that silicone once it cures and it dries, it does bond them to the actual liner itself.
Okay. And I'm stating the obvious. I know you guys already know this, but let's just agree on it that when you get to the convention center on Tuesday, great to bring your casing in. No energetics in the building.
Yeah.
Okay.
So we're actually, depending on time ways, we're actually looking at bringing in fakes, some like Play-Doh or something that we can simulate the mass and what they are, but obviously non-energetics, no propellants, nothing that can actually cause a fire hazard.
No ejection charges.
If you do that, label it as such, fake propellant or, demonstration only or something like that. Because there will be some people at the event who will lose their mind if they, okay. All right. So sounds great. So you have one test. I don't know. I mean, I don't want to say it was a failure. You had an outcome that wasn't, you had an undesirable outcome, but your systems all worked. You're all here talking to me, so that tells me that you were far enough away to, when observing that, and you didn't. Have you seen recently that the University of Central Florida burned 40 acres of property? So you had a place to do this that didn't burn. So
Right.
Good job. And
Thankfully, our flyer of record, Chris, provided us his ranch land for that, and there's an area within it that's specifically set up for motor testing. We were probably 200 or 300 feet behind where the motor was, and the motor was probably another 10 to 20 feet behind an 8-foot berm. So the only thing we were able to see was actually about 2 inches the very top of the motor.
Okay, all right. Except when the nozzle leapt into the sky, then you had a better view, I guess. But
well, so we heard about that fire. And I
Yep.
said, hey, if you guys can burn some of the rocks off of my property, I'll pay you.
Yeah.
And I didn't realize that they were going to take that as a legit challenge.
Yeah, challenge accepted, right? Yeah. That's Chris. I advise a lot of teams that if they have them available, if you can use like a local rock quarry or sand quarry to do your static testing, because as you mentioned, rocks don't burn. So that's great. I mean, if you got a ranch, use the ranch. You know, I forgot this is Texas. So
Nope.
yeah.
Okay, I have a question that y'all didn't cover.
Okay.
You didn't talk anything about rail buttons. And that's one of my pet peeves, right?
We need to talk about rail buttons for a second. All right, so we understand that the requirement for Ezra is to have a minimum of 2 rail buttons. The rail buttons cannot be epoxied and they must be through walled for security. We've upped that by using three rail buttons. And in order to do that, we wanted to make sure that by the time the foremost rail button left the rail, there was no possibility of weathercocking in any direction. So we added a 3rd rail button. The first rail button, so the first rail button will be essentially sandwiched. It will be first epoxied to the airframe, and then it's going to have 2 layers of carbon fiber tip to tip over the top of it, essentially making it embedded into the airframe. The second one is going to be a more sacrificial rail button. However, it is going to be mounted within the forwardmost location of one of our fin lock guides. Oops, up there. That will provide us an 18-inch span of the very last 2 rail buttons. The third and final rail button will once again be located on a rail button spacer that is located 18 inches above the, I was going to say, I got lifted up here. If we look at it in this direction, it'll be 18 inches, half of the forwardmost section of our 60-inch bottom tube. So essentially, over the course of the span, we will have 7.5 feet of rail button distance, and then we will have the final 18 inches of rail button to ensure that when this thing comes off the rail, in the last microseconds, it is still both actively controlled by the rail and passively stable by the fin sections. Both the forward rail button and the rear rail button, while yes, mounted on a spacer and epoxied onto the airframe, will be overwrapped, and therefore it will be part of the airframe. So instead of just having a through wall, we are actually using the airframe itself to store the energy of the rail buttons.
Okay, and are you just using like a standard COTS rail button? That I think I saw one on the.
Yeah,
15.
they'll be just normal 15-15 rail buttons.
Okay, good. I'm kind of glad to see that. I know that in the last couple of years, it's become fashionable to turn your own rail buttons out of aluminum. I really have a bad feeling about putting aluminum against aluminum. You know, I'm worried about galling. So I guess I'm glad to see that. And then my only comment would be with you won't be the only team there that has 3 rail buttons. You know, I mean, typically it's 2. Never 1, but typically it's 2, and the only thing you have to be mindful with 3 is you're going to need them to be absolutely perfectly aligned. You know, if you have 2, you know, you're creating a straight line between the 2 of them, and if one's off a little bit, you know, they're very forgiving. But having 3, you're going to lose that. They're going to have to be absolutely perfectly aligned, and I just encourage you to get yourself a piece of rail. Yeah, okay, all right.
Yeah,
test it. Make
kind
sure
of
it's
you're going with the aluminum versus the Delrin rail buttons. We experienced this on our first flight of the N4000. Our middle rail button was probably radially shifted by a 1/16 of an inch.
Yep.
And because it was Delrin, it quickly wore itself in on the flight up, and you could notice that when we recovered it. But unlike aluminum, it didn't gall into the actual launch rail.
Yeah. Well, and I guess the way I look at it is there's a volunteer out in the field that has to work with that rail for the whole rest of the day and stuff like that. And yeah, so be kind to your fellow rocket enthusiasts. So yeah, good.
A little bit of just overall launch stats and everything like that. Based on the new configuration, we should be at a 13 1/3 to 1 thrust to weight ratio. When it leaves the rail, it will be leaving under 2,002 foot-pounds of thrust. We have simmed this all the way down to an 8-foot rail, and we are stable at a 1.87 coming off the rail. We're hoping to launch off of a 16-foot rail just for the added stability factor. We've done all the grain analysis. None of the mass fluxes are of anywhere danger. We had a no-go line of 1.8 on any of the grains. The max we have is a 0.7, so we were way underneath that factor wise. And then on the backside of things, when we're recovering, we reread the technical document, and for some reason, an old number snuck in there. The velocity under streamer is 150 or 117 feet per second, not the 40 feet per second that was somehow stated in there. We didn't want to alert anybody because we know that thing's going to drift for White Sands and beyond. So we're coming down
Albuquerque, yeah.
Yeah, we're coming
Yeah.
at a high velocity, and then we have oversized our chute. So once it opens at 1,500 feet AGL, we're actually going to be descending at a 16 feet per second landing speed.
Good. Where your couplers are, how long did you make the part of the coupler that's going into the body tubes? One of them, the one that was going into the nose cone, looked like it was an entire caliber.
So each of them are actually 1.5 calibers.
No, the nose cones.
One of the nose.
Well, the one into the nose cone is one.
Is
The
one, okay.
Back is 1.5, and that's the same 1.5 on either side of the main center one.
Okay, all right. Yeah, I think you're not required to have 1.5 caliber. I think it's only one, but on a big long rocket with that much yeet, you'll probably appreciate. You don't want to turn into a pool noodle.
No, exactly.
Yeah, and then last year, I'm with Iowa State University, and we had some weakness in a coupler, and our rocket buckled like a cheap lawn chair. So,
Well, they have a pretty grumpy FOR.
okay, all right. I didn't know you said that about yourself, Chris. So I thought that was just all us talking behind your back, But okay.
No.
So, yeah.
There's a
So-
few things I'm really sticky about.
Yeah. Well, that is a really big motor, and that's a really big push. So it doesn't hurt to have a little more reinforcement in the couplers like that. Tell me about the ground testing that you for separating this rocket when you get to your events.
So you guys, did you not somehow you seem to have skipped over the fact that you actually already flew the whole airframe on a smaller motor?
Yes. Yeah, we've talked to Bill about this. So back in February, I think we sent you all the information.
Yep,
on the
you
launch.
sure did. Yeah, you sent me lots of updates. Yeah.
So thankfully, the airframe itself has been proven. Now it is trying to get the back end of the motor taken care of so we can get back to where we were prior to the KDO.
As far as the ground testing goes, with the injection testing, I'm not sure if you sent Bill the
Did
videos.
I send you?
Yeah,
those,
you sent me numbers. I don't have them up right now.
So-
yeah.
So because of how large the volume of is on our drug system, it seems like a very large charge, but we're going with an 8-gram primary and a 9-gram secondary. Once we did ground testing on those, I mean, we had great deployment of the forward end of the rocket, and we still had shock forward left to make sure we didn't hit a static snatch load within that. And then for the forward end to do the main, we are doing 3 grams primary and 4 grams secondary. And both of those have already been pre-tested. Prior to the next launch, we'll obviously still do a ground test. And then once we get out to Spaceport, we'll do yet another ground test just to make sure nothing has changed with the added elevation from where we go.
Okay. All right. Well, there'll be a lot of added elevation
Yes.
if everything goes right, so. Okay. How many people are you bringing to Spaceport?
We're up to 6 now.
Okay,
Originally there was about 3 or 4 of us, but we have, between asking different people, we're finally up to about 6 people for the full team.
yeah, I want to say that you're allowed to bring 5 people to the pad. So one person might have to stay back, you know, draw the short straw or something like that.
Yes.
And then of these 6 people that are coming along, how many of them have been to Spaceport before?
Yeah, I guess David has been.
Yeah, two people.
2. Okay, so I was just really hope that the 2 who have been there are overemphasizing to the 4 that haven't been there before, how important it is to stay hydrated so that you can survive the event. I know that you're in Texas, and I know that Texas gets hot, but most of us don't hang out for 10-12 hours a day in the elements like that, and just because my job, you know, like I say, I'm wandering around the campus looking for what's going wrong, and every day there's a couple of young people in the tent getting themselves an IV that they said, yeah, I was doing great and I fell over, you know. I mean, so just make sure that you emphasize that just because you're from Texas doesn't mean you can't get crispy down there. So yep. How I'm just curious, how are you transporting your motor?
So we did a bit of dumpster diving last week, and we just happened to find a boxed out crate that will fit with the airframe disassembled and the motor disassembled perfectly within it, and then that can be loaded onto one of our vehicles.
It looks like it was like designed for rockets, and we just found
We
it.
just found it. So we're going to build cradles on the inside of it, and each one accepts the outer diameter of what piece it's going to go in, and then the lid will have the mating side of the cradle, and then once they get secured in there, we won't have to worry about shifting or damaging.
Okay, you can stencil Acme rocket on the side of the box or
Yeah.
something like that. Yeah. So, okay. All right. That all sounds good. And
Well, they are the Roadrunners, so they could put Coyote and the Roadrunner on it too.
okay. Oh, so then it was just they would have the whole thing. Yeah. Yeah. So awesome. And you know, well, what are your housing? Are you staying in a hotel? Are you renting an Airbnb, or what are you?
So we're going to rent a Verbo, essentially an Airbnb, but that
Yep.
way we can have access to the whole house and use the space as we need to in case we need to do final like last minute integration or electronics repairs. We're not stepping on top of one another.
Okay. I'm not an attorney or anything like that, but just make sure you read the agreement. You know, like whether you're, bringing energetics into the garage or something like that, you know. And so just because we're one tragedy like that away from this whole thing not being an event anymore, you know. So okay. All right. I have what I need. Do you have any questions you want to throw at me? I cannot know. I mean, if I don't know the answer, I guess I'll just burst into tears and hang up on you or something like that. But yeah.
What are do you have any like hard cutoff requirements as far as actual like hot fire data, things like that for the motor?
No, I think you said you're doing it this weekend, right? I mean, yeah.
Well, let's just say like something happens and we're not able to do it this weekend.
Right. I think if you're able to show that you've got, you come to Las Cruces and they'll say, hey, we don't see, you didn't submit anything that you did, you did the required tests on this. And you'd say, well, yes, as a matter of fact, we did. And you show that that'll be okay. Yeah. I would rather you do it right than fast, because it's when you rush or have go fever, that's when things go, instead of going wrong, they go terribly wrong. So yeah.
I guess that's a good segue. We are actually putting together a go no go binder as far as wind speeds, what we're capable of, and what we were saying yes launch it or no, tell the pad crews to pull our rocket down because we're not launching for that day.
Okay. One thing I recommend in whatever SOP that you write for doing static testing, box that in, make it a limit that you can only work from sunrise until sunset. And write down what time sunset is on the day. And I know it's the spring and the days are getting really long. You know, we're up north here. Sometimes the sun never sets, it feels like, you know, but if you look at the videos of other universities that have had some things go really wrong, almost always in the background, I can see it's nighttime, you know, and what I remind my students here is sunset is actually about 70 to 100 minutes before it's dark. You know, so just, you know, sunset, it's still light out. You can drive without lights on your car and the sun, you know, and just make sure you're not, I'm seeing a common theme in things that have gone really wrong. And that's one of them is working not after sunset, but after dark. So just agree to that and don't do that. So.
And we can say as firsthand accounts, that's actually when our motorcade owned.
Okay. So, all right. I think I've got everything I need. So you can go ahead and you can capture this video and upload. I think there's an email address that you send it to. I have to go into HeroX and mark that we've completed this. You know, obviously, your rocket isn't completely assembled, but I can see, you know, it's you have made meaningful progress to where you go, and you've also had some setbacks, but you keep going, and that's awesome. You know, I admire that too. So if anything comes up, you can email, call, whatever, and we can figure that out. But congratulations, it looks really cool, and I can't wait to see you launch that. So
Thank you. We'll definitely send you the links to the hot fire and
Yep.
the links to the test fire as well.
okay. All right, well, thank you, and thank you, Chris, for tuning in, and see you in Las Cruces.
Yep. Take care.
Yep. Bye-bye.